Hello everyone, Harry here. Welcome to Scrap Science. It has been many years since I've made a purely electronics oriented video on this channel. In the very beginning of the channel, the idea was that I'd make a mixture of chemistry and electronics videos, but then what happened is that my chemistry videos got more views, and I also became more interested in chemistry than in electronics. I suppose electrochemistry is a mix of the two in a way. Anyway, I still like electronics a lot, and I've got a project in mind for us to do. I have a lab bench power supply that I use in a lot of my videos for the purpose of performing electrolysis. The current and voltage readout of this thing, however, I'm not really the biggest fan of. The LEDs in the displays are obviously multiplexed, which makes them flicker a lot in my videos because the shutter speed of my camera is faster than a single multiplex cycle of the display. Additionally, I have some power supplies that don't have a voltage and current readout. Ultimately, it would be nice to have a standalone device that we can put in line with our electrolytic cells, regardless of our setup and power supply, and that accurately tells us the voltage and current that we're running. I want something like that where it's easy to film and maybe looks a little bit nicer than what I've currently got. Making a voltage and current display wouldn't be too hard by itself, but I'd really like to use my favorite display technology of all time, the Nixie tube. If you haven't heard of Nixie tubes before, these are basically the same as a neon indicator light. If you power a neon indicator light with direct current, the cathode will glow with gas discharge if you give it the correct voltage. And Nixie tubes take this concept further. Inside these things, we have 10 possible cathodes to choose from, each of them shaped like one of the 10 digits, and then we have a common anode, which is the mesh at the front. If we choose a particular cathode to run current through, it will glow, so this is effectively a numerical display that we can control to display the digits 0 to 9. I think these things are super cool. It's odd to think about as well, to me anyway, but this was genuinely one of the most practical and convenient ways to display numbers in electronics for a long while during the middle of the 20th century. These things were used all over the world from maybe the 50s to the 70s, after which they were kind of succeeded by things like LED displays, liquid crystal displays, or vacuum fluorescent displays. Various places in the Soviet Union continued mass producing these through the 80s as well, and these 6 what we call IN-12 tubes come from the manufacturer Gazatron in Ukraine during that period. Though there are a couple of companies that have started making new Nixie tubes this century, because a lot of people like the look of these displays, there are enough extras from the 80s that these were really easy for me to get hold of. Plus, I really like the form factor of the IN-12 tube. I'm not really the biggest fan of the vertical tubes. Anyway, I want to turn these 6 Nixie tubes into a voltage and current display. But to do that, we need to figure out how to actually display numbers with these things. And it's complicated and interesting enough that I want to make a whole tutorial video about it. So, how do we actually build a circuit to drive these? If we start with just one Nixie tube, the circuit required to make it display a number is really quite simple actually. We first of all need some way of generating the necessary voltage to make the Nixie tube cathodes glow. This here is a flyback converter that converts 12 volts DC into 170 volts DC, which is exactly what we need. Additionally, I've got a 22,000 ohm resistor to limit the applied current. And then to actually make some connections to the Nixie tube, because these things don't just plug into a breadboard. If you have a look at the pins on the back, they're not exactly a conventional shape these days. I've bought some specific Nixie tube sockets, which I have soldered onto a series of pins that will actually just plug straight into a breadboard, like so. The circuit we need to drive one of these things looks like this. The positive 170 volt line just connects to the anode of the Nixie tube through our current limiting resistor. Then, if we have a set of 10 switches that connect the 10 cathodes to ground, or 0 volts, we can select which number we want to glow. Here's what that exact circuit looks like on my breadboard. With my 10 switches down here, sure there's 12, but I'm not using the last 2, I can display all 10 digits. So let's give that a go. Nice. I don't really like poking my fingers around these switches because we are directly switching 170 volts. So if you're going to be playing around with Nixie tubes, make sure you know what you're doing first. Even when floating, these cathode connections that I've made all across the board can often be held close to that 170 volt supply level. Anyway, this setup is great if we want to test a Nixie tube, but it's not really practical for a system that should be automatically displaying different numbers. For that, we need to make these switches electronic, not mechanical. Something we can open or close with a microcontroller of some description. For that, we can use NPN transistors. 10 transistors, collectors each connected to their respective cathodes on the Nixie tube, emitters connected to ground, and then the respective bases can be switched on or off through a 5 volt signal and an appropriate resistor. Applying 0 volts effectively gives us an open switch, and applying 5 volts closes the switch and turns the digit on. Of course, if we're switching up to 170 volts, we need to select our transistor quite carefully, and most standard NPNs won't do it. I'm using a specific kind of A42 transistor here, specifically one that can handle the voltage. And once again, here's the whole circuit constructed. Not the whole circuit, actually, admittedly. I've only connected 2 of the digits because I couldn't be bothered wiring up all 10, but just to demonstrate, all right, now I'm switching 5 volts instead of 170 volts. I can indirectly control a couple of digits. I suppose you'll have to take my word for it or look at my breadboard very closely, but these signals that I'm now sending with these switches are signals that could just come from a microcontroller. Now, while this works, and it works very well, there is a problem with this kind of setup if you actually think about it. If we want to drive a total of 6 digits, which again is how many I want for my voltage and current meter, having 10 digits per tube, which means 10 connections per tube, which means 10 transistors per tube, which means 10 digital signals per tube, overall that's 60 transistors and 60 digital signals that have to come from a microcontroller. Now, if we assume we're sticking with an Arduino based project, even the Arduino Mega doesn't have that many digital signals that we can send out from it. Also, soldering together 60 transistors and the associated circuitry that goes with them, that's a lot of work in my opinion. So there has to be a way to simplify this, ideally so that we can just use a regular old Arduino to control all 6 digits here. A somewhat obvious way to reduce the number of transistors and digital signals that we need to drive 6 Nixie tubes is through the use of multiplexing. With a multiplexing setup, we can have just 10 transistors wired in parallel to all of the 10 digits of all of the 6 Nixie tubes. Now, of course, if all 6 Nixie tubes were powered at the same time, they'd all show the same number under this regime. But the idea of multiplexing is that we only turn one tube on at a time, sequentially, so that we can display a different digit on each one. Now, there's 2 reasons I don't really want to go down this route. Number 1 is I don't really like multiplexing. It makes whatever you're displaying a little bit dimmer, because of course we only have each Nixie tube on 1/6 of the time if we were to do this in our setup. Other than that, I'm not really sure if there's any technical reason for us to try to avoid multiplexing. Nixie tubes can definitely be multiplexed. I just personally really don't like multiplexing unless we really have to. And reason number 2, multiplexing is one of the things that we actually wanted to get rid of by building this new voltage and current sensing device. If we recall, multiplexing the digits is why my old power supply doesn't look good on camera. So, no multiplexing, we can't really cut down on the number of transistors that we need to use to drive all 6 Nixie tubes, but what we can do is cut down on the amount of work that we need to do to put the circuit together. What I mean by that is that there exist Nixie tube driving ICs, like this one. Inside this little integrated circuit here, we have all 10 driving transistors wired up in exactly the way that we want them. Additionally, this chip comes with its own binary to decimal decoder. So instead of requiring 10 input signals, it only requires 4 input signals in the form of a binary input. The Nixie driver integrated circuit that I've chosen for this is the K155ID1. I'm told it's not the best Nixie driver in existence, but it is the only Nixie driver that is still being manufactured today, I believe. If we have a look at the date code on this, 2401, that means the first week of 2024. This was manufactured less than 2 years ago. Anyway, here's the circuit that we would require to drive one Nixie tube with the Nixie tube driving IC that I have. 4 input signals in the form of binary, 0 to 9, and then 10 output lines of the driving IC, each connected to its own digit on the Nixie tube. Based on the binary input, the Nixie tube driving IC will drag one of the outputs down to ground, lighting up the digit that we want on the Nixie tube. And here's that circuit fully built. The Arduino here is not for any kind of digital signal or anything like that. I'm just using it as a stable source of 5 volts to power the Nixie driving IC. Turns out the cheapest 5 volt buck converter from eBay sometimes gives you 4.5 volts instead of 5 volts. And that really messes with the Nixie tube driving IC, or so I've found. Anyway, in order, up the top of this breadboard we have our 170 volt generator powering the Nixie tube. We have the Nixie tube itself. Kind of underneath, hiding down there, is our Nixie tube driving IC connected to all 10 digits. We have some pull-up resistors on the digital inputs. We have switches to send the binary input, and then LEDs to visualize the binary input as well. Sadly, because we're using a pull-up resistor system and the switches are switching down to ground, a 0 is an on LED and a 1 is an off LED. So you just have to keep that in mind as I demonstrate this thing. Anyway, if I'm very careful and precise, I should be able to switch these switches to give you the digits from 0 to 9. So let me have a go at that. So just by replacing our 10 possible NPN transistors that we would need to use to drive one Nixie tube with a Nixie tube driving IC, we have simplified the soldering immensely because all of those transistors are contained in one little IC package. And we've also simplified the digital side of things, right? From a microcontroller, we now only need to send 4 digital signals instead of 10. Overall, that brings us from 60 digital signals down to 24. Now, 24 digital signals is a lot better than 60, but it's still quite a lot. In fact, it's still significantly more than the standard number of digital outputs on an Arduino Uno. So the question is, can we make more efficient use of our digital signals without just outright multiplexing? The answer, of course, is yes, we can, but we have to be kind of clever about it when we do it. To explain this, we are going to be kind of taking inspiration from multiplexing. Say we have all 6 Nixie tubes hooked up in a multiplexed system, each one with its own Nixie tube driver IC. That way, only the 4 binary signal data lines need to be in parallel, and then in the traditional multiplexing sense, we turn on each Nixie tube one at a time. Once again, this kind of multiplexing can be done with Nixie tubes and it looks quite nice to the human eye. But when we're filming things, due to the shutter speed of the camera that I will be using, it's going to look significantly worse. The main problem here is that each individual Nixie tube is off for more than 80% of the time. So it would be really nice if we could multiplex in the way that I've just described, but instead of the tube turning off when its turn is done, it just remembers which digit it was supposed to be until the next time it's activated on the multiplexing loop. What we're suggesting here is that each tube in the multiplexing chain has its own memory system so that they can still share the 4 data lines to send the binary signal from 0 to 9, but then they don't need to be turned off, so they remember the signal that was sent before. The answer to doing this, of course, is with another integrated circuit. So this is the 7475 IC, and what this essentially is it is 4 bits of memory. 4 inputs, 4 outputs, and then 2 enable pins. If we put those enable pins up to 5 volts, whatever is on the input pins will be transferred to the output pins, whether that be a 0 or 5 volt signal on each line. And then when we pull the enable lines down to 0 volts, it will simply remember what those initial inputs were, and regardless of what you put on the inputs from that point on, the outputs won't change. This is perfect for remembering a 4-bit binary signal. So here's my proposed circuit. It's the same thing as before, except the 4 binary input lines of our Nixie tube driving IC are now connected to the 4 output lines of our 7475 IC. The 4 input lines of our 7475 IC are then connected to the outputs of a microcontroller, and then the enable pins on the 7475 are also connected to their own output on the microcontroller. With this setup, anytime we want to change the digit that a Nixie tube is showing, we just send the binary signal that we want, 0 to 9, and pulse the enable pin, and then it will just continue remembering regardless of what those input lines are. Let me show you this in an actual circuit. From top to bottom, hidden behind the Nixie tube, we have our 170 volt generator. We have the Nixie tube. Hidden kind of under the Nixie tube just there is the Nixie tube driving IC. Below that is our 4 bits of memory IC. And then we have our binary input switches, and also the last one, the enable pin. Once again, I will remind you that the 4 LEDs over here are just as a representation of our binary signal. An on LED is a 0 and an off LED is a 1. An annoying convention for me to use, but it was the easiest way for me to build this circuit, so you'll have to get used to it for now, I guess. Final little addition to this circuit is this LED. This is a visual indication of our enable pin. An on LED means that the enable pin is off or to 0, and an off LED here means that the enable pin is on or a 1. Anyway, the way that this circuit works is, because we have these 4 bits of memory directly tied to our Nixie driving IC, no matter what we do to the input of this IC, let's say that was a binary 4 there, if we give it a binary 6, we can even give it a binary 7. No matter what we do on the input side, it doesn't change what the Nixie tube is outputting because we haven't enabled the 7475 IC. It is only when we pulse the enable pin, watch the LED on the bottom right, that the 4 bits of memory IC actually puts 7 on the output. Once again, now that I've turned the enable pin off, we can change whatever we like on the input and it won't change what the Nixie tube is showing. Just to demonstrate that again, let's send it a 4. Again, binary 4 over here, and then pulse the enable pin. We switch the Nixie tube to a 4, and now no matter what we do on the input side of things, really doesn't change anything. One final time, let's send it an 8. This is binary 8 right now, and if we pulse the enable pin, very nice. So now hopefully it's becoming clear, if we wanted to drive 6 Nixie tubes like this, each one with one of these circuits on it, what we can do is we can tie all 4 data lines, the binary input, in parallel. They can be shared between all 6 of the Nixie tubes. And then all we need to do to have full control of every single digit is have a separate enable line on every single digit. So 4 lines to send data, 6 lines to select each Nixie tube. And finally, if I've done my maths right, 4 plus 6, that's 10. We only need 10 digital outputs from a microcontroller, which is very, very, very doable with an Arduino Uno. Of course, the only kind of complication here is that every single Nixie tube needs its own circuit like this. So it'll be a very modular system, but it will be quite a bit of soldering for me to do, I think. Originally, I was going to solder together 6 copies of that circuit on, I think these are called perf boards. Obviously though, that would be a lot of soldering. I don't really want to have to solder together 6 copies of that. So I got a bit smarter and just went ahead and ordered some PCBs of that exact circuit. Now, I'm no expert in PCB design yet. This is the first PCB that I've ever designed and got printed. So I haven't done any of the normal things that you do when you make a PCB, like use decoupling capacitors or a ground plane or something like that, but it will work, I guess. So additionally, I've also gone ahead and soldered together 6 copies. As you'll note here, this contains everything from our circuit before. We have our Nixie tube driving IC and the 7475 IC and all of the internal connections that will make this work. You'll also notice I've kind of like daisy chained them together because we've got our 170 volt line up the top that powers the Nixie tube. We have our shared 5 volts and ground that go across all 6 of them. And then of course we've got our 4 signal lines for the binary input. Again, these are shared across all 6 of the Nixie tubes. If we flip this over, we have some pin headers that will allow our Nixie tubes themselves to just plug straight in. Try to ignore the bodge job that I had to do on each of them because I misrouted 2 of the PCB traces. Again, just don't look at that. Right, now everything is connected up and I can finally show you how this whole system is supposed to work. As always, we've got the Arduino just providing us a stable source of 5 volts. We've got our 170 volt generator on the right here powering all of the Nixie tubes. We have the switches over here that can input our binary signals, and then our 6 switches over here that go to each of the enable pins on each of the Nixie tubes so that we can select which one we want to send the number to. The procedure is we kind of dial in whichever number we want to send, and then we send it to the appropriate Nixie tube. Let me turn it on and we'll do a demonstration. Right, currently the numbers that it's displaying are just kind of random because we haven't actually sent anything to the Nixie tubes yet. It's just naturally what the 7475 IC already thinks the number is. So first of all, we're currently sending 0, so let's just send a 0 to every single Nixie tube. To do this, we'll just pulse all of the enable pins high. And now we've sent a 0 to every single Nixie tube. And to display whatever number we want, all we need to do is just go one at a time, make the number over here in binary, and then send it to the appropriate Nixie tube. So I'm going to try to make the number 345678. Takes a little while to do manually, but you can imagine if we had a microcontroller hooked up to all of the 10 data lines, that would have been a very quick job. It also would have been quicker if we had 6 buttons instead of 6 switches for the 6 Nixie tubes, but I forgot to buy buttons, so we have to just use the switches. Anyway, I think I am going to leave the video there for now. We have fully built our Nixie tubes, we've fully powered them, we've made them capable of displaying any 6-digit number, and I think the video is long enough at this stage. So the rest of the project we'll put into part 2, maybe even part 3, where we will be actually building a system that can measure voltage and current and actually display it using these digits. For now though, I hope you enjoyed the quick break from my usual chemistry content, and I'll see you later.